Okay, I have turned on the recording, and I believe I'm now recording. Today is August 20th, 2017. This is the scheduled meeting of ITSE 2309. The tests I finished grading the tests and turned them in for everybody. That the grades on computer science tests will typically have two groups. One group is very high. I had quite a few hundreds, or close to it. And one group is fairly low, meaning very low. If you are one of those that is low, anybody listening to the recording, not pointing at anybody in particular, I will give you the option of redoing or raising the grade to a passing grade. If your grade was 89 or 85 or something like that, that's not a low grade. So um, I'm not going to do something like that. But if your grade was low, then we can talk about bringing it up. But I'll need to see you in lab, meaning uh, here on Fridays, and I cannot require someone that is in the online class to come to lab. But if you're not doing well in the class, maybe you need to come to lab. Okay. I was going to go over the test a little bit. I don't think I will, since I'm getting a little bit of a late start, almost 15 minutes into the class. Um, have I got audio? Can you tell? No, you can't tell, or no, I don't have audio. No, there's a good idea. Okay. Yeah, one of the thorniest things I ever chased was one time at a college, Texas A&M in Corpus Christi. Somebody set up their computer in their dorm as a DNS server, and so every time it would come on, we'd lose DNS to the dorm, and they'd turn it on, and we'd be looking for it, and we'd almost find it, and then they'd turn it off, and so it would come back up, and it was definitely a pain in the neck. Okay, let's see. On the test, I ask you questions one through 4 or 5, I believe. Ask you things about primary keys and foreign keys. I ask you to 1 through 5 weren't writing any queries. It was just creating 2 or 3 tables and building a setup where you had creating a table with a foreign key and a primary key. Hello, Matthew. I see you have joined. Matthew, would you send me a text or something on if you can hear the meeting? I'm trying to send you a chat. Type message here. Type message. Okay. Can you hear me now? And I have okay, that was you. You're Matthew. Yes. Okay. And you can hear me. Good. Cool. I'll leave the chat window minimized. So if you aren't able to create a table with a foreign key and primary key and constraints, we need to see you in lab. And let's see. Most of the questions that I ask, like why did a query fail? It failed because there was an unmatched, by deleting a record from the parent table, I believe it was the vendors table. If you delete a record from the vendors table, and it left a dangling foreign key in the invoices table, it's going to fail. And that's what I was looking for there. Somebody tell me that you should have told me for 5 points. Told me that. Then we went into a couple of inner joins, and then there were a couple of outer joins. One of them was to find we have invalid data in a table that the foreign key is not set up, or what was not set up. Somebody was able to enter an invalid foreign key. It was there. And if we tried to turn on the constraint and check it, it said you can't do that because there are invalid data. So I was asking you to find, I believe it was from terms. Terms was the foreign key. I don't remember what table it was, but one of the tables had an invalid foreign key in it because I put it there. And that would have been an outer join to have found that. So basically I did 2 inner joins, 2 outer joins, and then one, the last question, I was fairly lenient on it, had asked for both an inner join and an outer join in there. I didn't feel that the test was real hard, and when I see, as many high grades as I did, meaning you generally speaking on a test, I grade tests fairly hard. I allow you to use your books. I allow you to use your notes. Therefore, I tend to grade the tests a little hard. I have kind of a sliding scale that I use depending on, it's easier to get from a 69 to a 70 than it is to get from an 89 to a 90, is the way I look at it. Okay. One other thing on following directions, I ask you very clearly to put problem numbers in there, and lots of people didn't. I took off some points if you didn't number the problems. On syntax, when we use the word join, it will always be preceded either by the word inner or outer. Now you can just say table A join table B. Yes, that works. You get an inner join. But I would like for you please to say inner join. And again, you can say left join. You will get a left outer join. I would like for you to say outer. So at least for this class, let's always adopt the idea that we're going to say explicitly inner join or outer join. We covered two types of syntax to use for an inner join. One of them is the old implicit syntax where you just, from table A, comma, table B, where table A dot primary key is equal to table B dot foreign key. Okay, it will always be on a join. We'll always have, in this class anyway, always one side of that join will be a primary key. The other side of that join will be a foreign key. Now, it doesn't always have to work that way, but it will in this class. They either have to be a primary key or it has to be unique. If there's multiple values in there, strange things are going to happen. If you're joining on a field that has duplicate values or could have duplicate values. For example, I saw a lot of people joining the vendor name to the invoice ID in the invoices table. That doesn't make any sense at all. Where does the vendor name equal the invoice ID? It might. It's just an accident. It's like joining somebody's IQ to their shoe size. Yeah, I'm sure you'll get a few people. Okay. The questions on that, email me. And I need, if you're not doing well on the test, I need to see your smiling face in lab. Is the bottom line. So we can work with it. Okay. There are still some stuff that is outstanding, some grades I haven't, some assignments I haven't graded yet. and I'll try to get those caught up. But my main focus was trying to get the test. The test is the big one because I spend a lot of time grading that. Questions? I guess Matthew's the only one that's joined our little meeting here, but I guess the rest of the people can listen to it. We are in module. What is this? Module 8, and we are talking about subqueries. PowerPoint slides, I guess I'm going to bring those up and open that. We will take a look at them as we go. Next is on syntax. At this point, I do want you to use the full syntax. For example, we can drop the keyword as, and SQL will let you drop it. You can just say from vendors, vendor name as VN, can just say vendor name space VN. If you have another field there, it would be a comma after the VN, and you would just continue with your fields. So the as would go between these two guys. Yeah, SQL will allow you to drop that. I don't know that it's bad. I don't know there's anything wrong with it, but I've started out saying I want you to use the full syntax. So humor me, use the full syntax, put as in there. Similarly, I can, from vendors space V. Term inner and outer may be skipped. A join B, I've already talked about this. And we're going to use the full syntax. Okay. So if you don't do that on a test or an assignment, I will probably I'm not going to you won't fail over it, but I won't be happy. Similarly, semicolons, we don't use. If you write code that doesn't have any semicolons at the end of a statement, if you forget one of them, it's not a big deal, but don't give me 9 or 10 problems that have no semicolons at the end. That will not run in an Oracle environment or in MySQL. It will not run. SQL Server lets you go ahead and get away without it. It figures out where the end of it is. But if you try that in Oracle, it isn't going to run. Similarly, many of the over here. Many platforms do not allow you to have a space actually in a SQL query. So there's an SQL query. Inside of that query, from where you start and say select and open it until you get to the ending semicolon, you cannot have a completely blank line. You can have a comment on that line. So if you want a blank line, just put a dash dash on that line and it'll give you a blank line. Now, in between that, down here, blank lines in between them are fine. It just skips over those. But inside of a query, inside of an SQL statement, many platforms will throw an error if you have a blank line in there. So SQL Server lets you get away with it. But I don't want this to be a class about SQL servers, a class about SQL. So we're going to try to write pure SQL. For this reason, I'm not going to cover in detail, let's see, last class period, or maybe it was one before that, where we covered the roll-up. Last class period, I believe we covered roll-up, cube, grouping sets, and one other one anyway. And I said I didn't like those. Why? Because they are unique to SQL Server, and they throw extra information into the subquery, into the query, besides just a table. In other words, different rows will mean different things. And that really doesn't belong in SQL, pure SQL. It's not pure SQL. It's Microsoft's version thereof. So we're not going to cover that a whole lot. Okay, I have introduced the idea of the subquery. This particular video that's on here is a good one. I'm not going to play you the video. You can play the video just as well as I can play it to you. I could hit play and we could listen to it. It's fairly good. I like the presenter there. He talks very, very fast, but he gets the job done. We need all of the vendors' names who have no associated invoices. So, based on what we know, before we got to this chapter, how would we write that query? Unmatched records, outer join. And right underneath that, you can see it's vendors and invoices, where I need all of the vendors. So the outer join points to the table that I want them all from. I usually I write the one with the primary key in it first and the one with the foreign key in it second, but you don't have to do that. But the outer join points to the one from which I want all records. I'm going to get everything from the vendors table. Vendor ID equals I.vendor ID. When I alias a table, the reason I alias a table right now, at least, is so that I don't have to type the darn thing. So I will typically alias it with a single letter, even though our book doesn't do that all the time. Sometimes they give them strange names. I will typically, if I'm aliasing a table in the join line, I will typically use one letter. You don't have to. It's fine. You can say where vendors.vendor ID equals invoices.invoice ID if you like typing. You're probably a faster typist than I am if you do that. So we have a simple outer join. With me? Now, I noticed some things about that outer join. Everything I am selecting comes from one table. Everything that I am selecting comes from only one table. If I want something from both tables, so if I want the vendor name and something from the invoices table, which would be unusual for this kind of query because I'm wanting them where it's null. So all I'm going to have over there is nulls. If I answer the question and I give you the vendor names that have no query, there isn't any point in selecting anything from the invoices table in this particular case. Everything is coming from the vendors table. Do you see that? Only vendor name is in the vendors table. It isn't in the invoices table. When I have this, I tend to think of a subquery. To me, it is more intuitive than an outer join. I personally like subqueries. I'm a big fan of them. Let's take a look at the subquery. This is the same query. Select vendor name from vendors where vendor ID not in. Select vendor ID from invoices. Is that pretty intuitive? I believe it is. observations down here. The syntax requires this set of parentheses around the subquery is required. Indent the subquery within the parentheses to make it easy to see. Don't just run it all up against the left margin. Indent it one tab or whatever. I don't think I have tabs here. Syntax requires. Some people believe, I am one, that a subquery can be more intuitive than a join. Most joins, not all, most joins can also be written as a subquery. So we're going to go back and revisit some of the joins we have written, and we're going to write those as subqueries. In general, a subquery is not any more or less efficient than a table join. In fact, if the system wants to or makes a decision that it's better, it can go ahead and join the tables instead of the subquery. Subquery is just the logical way of stating the problem that you want solved. How the computer does it, the plan of execution, is up to the system. Okay. So whether you write it as a join or a subquery is irrelevant. Although I want you to, we're learning subqueries here, so I'm going to tell you on this module, we're going to write them as subquery. Professor King raised a good point in the video. Do not use the distinct keyword in the subquery. Okay. We don't care about distinct vendor ID. All we want to know is a vendor ID, it's either in the set or it's not in the set. If you add anything to it, if you add an order by or a distinct keyword into that subquery, keep the subquery as simple as possible. Adding a distinct in there would cause it to run more slowly, because now I have added something to it that the system can't just filter out. So if I give it just this select vendor ID from invoices, fine. We use the in key. Next. I believe I raised this one last time. A subquery is very handy for finding a maximum value or a minimum value when you might have ties for that maximum or minimum. For example, find the vendor ID or IDs with the highest invoice total. Okay, now this query will show me that information. Select vendor ID, max invoice total. I don't know why I named it ITOT. It looks like idiot. I don't know why I chose that name. Something about invoice TOT. Okay, invoice total. From invoices, grouped by vendor ID, order by ITOT, descending. And then I tell you, hey, just look at the top. Okay. And there's some other stuff that I can do with that. I could eventually tease out just the top single value. Just go look at the first few lines. And that's considered sloppy. First of all, I returned more fields than I was asked for. I wasn't asked for the invoice total. I was simply asked for the vendor ID. And I returned extra rows. And then I put down there, I cannot use a top clause. No one, I don't like top. Because that implies the ordering, but it's okay because it's ordered by in the query. And I don't know how many ties I will have. I say I could have 1,000 ties for the top. I don't know how many to tell you to take. So I might have one that's the top. It doesn't have any ties. I might have 10,000 in there that all tied for the top value. Okay. This is the place where we really like a subquery. A subquery here is beautiful. It's exactly what we want. Finding the maximum or the minimum. This one, I only get the vendor ID. I only take the vendor ID from invoices where invoice total is in. Select max invoice total from invoices. That's going to just return me one value in that subquery. Is just going to return me the number that is the maximum invoice ID. And then I go through, apply the outer select the vendor ID from invoices where the invoice total is in there. So if I have one of them, and I'm pretty much guaranteed to have one, otherwise I will have however many I've got. Okay. What if I wanted the invoice total also? And I say like this, select max invoice total from invoices where invoice total is in, and here I will get an error message. So why? Well, I tell you that right in the next line. Why am I getting an error message? In the outer query, I have an aggregate function, and I have one that's not, that says I have to group by vendor ID. If I do that, if I add that group by vendor ID to the outer query, everything's going to be fine. I don't need to group by anything on the inner query because I'm only selecting the aggregate function. It's just going to apply to everything. It's going to find the maximum invoice total in the whole table. Questions? Finding maximum or maxima or minima, or I suppose if I wanted to find any that were exactly equal to the average, chances are that it would be not, that I would not have anyone. I mean, how do you find someone that's exactly average? There probably aren't any values that are. Next. I talked about this last class period. I'm now on slide, what slide am I on? Module 8, page 3. And this topic is covered in page 188 through 193. And we saw that where it's in. And I'm pointing out that it is sometimes written as equal to, where it is equal to. And you remember my discussion from last class period, where I said I don't like equal to because the things on either side of that equal to are not the same thing. So there's a bit of a logical disconnect here. I'm saying, is a number, invoice total, equal to the table, that subselect, which is going to return a table. Okay. Equal to should not be used there, in my opinion. Use in instead of equal to. Now, I talked about one other thing, that when the subquery returns exactly one column and one row, equal to will work if you test it with a number. So I'm returning exactly one value, and I only get one row. If I put equal to there, it will work. But why? Just put in. It's either in the set or it's not in the set. And if I put in, then it works with more than one row. So I can have as many values in there as I want. For right now, I'm not going to cover what happens with a subquery that returns multiple fields. I don't want to deal with that right now. Right now, subquery, if you're using it like this, just simply return one field. Find all of the vendor IDs that have an average invoice total, whose invoice total is greater than the average invoice total. Okay, so if vendor ID 3 has an average invoice total, select all the vendor ID invoice total pairs where the invoice total is above average. So find everybody that's above average. In that case, I will have to use the greater than operator, and the greater than is part of the what we call the trichotomy, greater than, equal to, less than. So it implies that there is also an equal to being used. Greater than has the same issue, but there it's not, you can't write it any other way. We do have this query. Let me pull down a little bit. Greater than all. Now, I like that a lot better, because if I said where the invoice total is greater than everything in this set, that is more logical, because once I say all of that set, I am talking about go in and compare it to each one of them. Now I'm a little bit happier with that. So if you use when you say greater than all, use the all operator. It's better. Even if there's just one item in the set, it will still work. All will still work. The other thing that's interesting about all is its behavior on nulls. If you are comparing it against a null, greater than, less than, equal to, all of them will be false. So if I compare something to null, it's going to be false, whatever it is. So if my subquery returns nothing, then is it in there will be false. Is it greater than nothing? False. Is it less than nothing? False. Okay. So that's something to keep in mind. Subqueries tend to have better behavior, in my opinion, on nulls. Scroll down a little bit. Bottom line, when you're comparing a value for equality or inequality, I would like for you to use in, please, instead of equal to. When you're comparing to a value to greater than, less than, please use the all keyword. There is another keyword that is any. It also works with equal. It says, is it equal to anything in that set? I just prefer to use the in, and it sidesteps it. Is it greater than anything in that set? So if you use all or any, we will generally be using all. And now the fun begins. I suggest you listen to Dr. King's video also. It's nice to hear somebody besides me. Okay. Please review the idea of the self-join covered on pages 134 and 135. Self-join. What did we do with a self-join? What kind of questions did we answer with that? What's that? Right. To table A joined with table A. In other words, we're joining the table. what kinds of questions did we answer? There's a set of things that we answered. Okay. Show me all the supervisors, employees, pairs. Let's see. Show me the list of all of the vendor names who live in the same city. Remember that one? Okay, I want a list of all the vendor names who live in the same city. And let's see, there were some issues there because we always would get back vendor name Jones lives in the same city as vendor name Jones. So I live in the same city as I live. So we'd have to filter that out where my ID my ID in table 1 does not equal my ID in table 2. Probably don't want to see that one. Maybe I do. The other issue that you will see in a self-join like that is that if I live in the same city as Donna, then Donna lives in the same city as I do. So I will get the pair, Stephen, Donna, and I will get the pair, Donna, Stephen. There's some ways around that, but to just get one of them. Okay, so subquery can work there in place of a table join. Let's consider a variation. Question of finding the vendor ID with the greatest invoice total. However, I want each vendor ID and the greatest invoice total for that particular vendor. So I can do this as an inner join with itself. So I'm going to join invoices with invoices where the vendor IDs are equal, group by vendor ID and order by the max. Let's see how this runs. I think I have it up over here. Okay, this is that code, just paste it in. Vendor ID. So I'm taking it all from one table. Enter join as I2. And let's run this. Take a look at what we got. 34 rows. So for each vendor ID, I have his or her maximum ID. I'm ordered by max. So I see 110 has the greatest maximum ID. Vendor ID 72 as the second largest maximum. And so on down through 97 has the smallest maximum. Okay. So here's the join invoices. I must alias these two. Why? Because how will I tell them apart? So I'm taking everything from I1 and invoices I1, invoices I2, grouped by vendor ID. I have to group by vendor ID because I've toggled that rule. Order by my max. Okay. This one can also be written as a subquery. Now, here's what makes it a correlated subquery. Let's take a look at this subquery. We're selecting vendor ID, max invoice total as my max. Now look at line 33 up there on the board. From invoices as, I named this one INV outside. Instead of naming it I1 and I2, I wanted to highlight that this is the outside query, invoices as outside, where invoice total in, select max, from invoices as INV inside. Now, line 38 is the line that makes this a correlated subquery. Lots of times you'll hear people talk about a correlated subquery. What makes this guy be a correlated subquery is in the subquery, it references both tables, both the table from the inside query and the table from the outside query. The table from the inside query is not visible outside, but the table that I named from the outside, where I gave it a name, is visible inside. So line 38 up here on the board is the line that makes this be a correlated subquery. That's essentially the line that does the self-join. This is why they have to be aliased. And both the inside and the outside. So if I use the name of the outer table inside of the inner in the inner subquery, since I'm using that one from outside, I'm using this name. It's named out here, and it's used inside. This one, INV inside, is named inside the parentheses and used inside the parentheses. Now, the rules here are the same that would apply to, have we had C++ in here? In a programming language, if I open a pair of curly brackets in C, for example, or Java, and I declare a variable inside of there, it is not visible outside. If I declare something outside, it is visible inside of those. So I can look outside of a pair of parentheses, but I cannot look into it. Does that make any sense? I can see things that you've named outside of that subquery, but from the outer subquery, I can't see anything that's going on in there. All I can ask is invoice total in there? So in looks inside, is that value in there? But I can't see the name INV underscore inside from outside of those parentheses. But I can look out and see INV outside. Have I lost everybody yet? No, if I were to go into, let me, pull up Notepad here. I don't think I've got anything here I need. If I have a C or a Java program and I have a curly bracket open and I say int I gets 10. Okay, I have an integer named I. Then coming along later, and I open another set of curly brackets, int j -13. The I from outside would be visible. Okay. I would change I outside. So line 8 would reach outside and change the variable that is outside of those brackets. Down here, if I tried to say j gets 0, I would get an error because I cannot look inside of those brackets. But from inside, I can see outside. This is also true in database. Inside the parentheses, from inside of the parentheses, I can see outside. But from outside, I cannot see inside. Group by vendor ID. And this shows it because out here, I can just say vendor ID. I don't have to qualify which vendor ID I'm looking for. There is only one table with a vendor ID in it out there. Questions? As you get into correlated subqueries, there's a very powerful idea. The thing that makes it a correlated subquery, if I say it's a correlated subquery, I'm looking for you to use both tables in the inner query. Okay, so essentially a correlated subquery is a self-join. To find all of the, I could find the pairs for right now. I'm going to say a correlated subquery is useful when everything that is output, listen to this, everything that is output comes from one table. I only need stuff to come from one table. So everything here comes from the outer table. I cannot select anything that comes from the inner table. Questions? This, by the way, will show me the same information. Except this time I grouped by vendor ID. I don't know why I grouped one by vendor ID, ordered by vendor ID, grouped by vendor ID. I forgot to order this one. Order him. Now we should have the same 90. I didn't say descending. I did say that. So vendor ID 110 is still the greatest. I forgot to say descending. I should have said descending. Now they are the same. Finally. So both of these will produce exactly the same output. This one is a self-inner join, and this one is written as a subquery, as a correlated subquery. Correlated subqueries and self-joins are typically the same. And that's the way that Dr. King approaches it also. He's got a good take on it. I like his approach. I am comparing a correlated subquery to this one. The best way to understand it is to see one that is not a correlated subquery. The one that is highlighted on the board right now, and yes, we're going to take a bathroom break here in just a second. One that is highlighted is not a correlated subquery. How can you tell by looking at it? It's immediately obvious is I did not alias the tables. It cannot be a correlated subquery unless I've given the table aliases. So I have to give it to name them something different. I have an invoices up here in the outer query, and I have invoices in the inner query. That is not a correlated subquery, though. Why? They are two different identifiers. The one in the subquery cannot be seen. It does what we call shadows it. So it's a totally different variable as far as this guy is concerned. It would be like, let's go back here. What if I were to declare another integer named I inside of that curly bracket? So it's a new name, a new integer. That's legal. I've got one out here named I and one inside named I. Perfectly legal, but they are two different variables. They just happen to have the same name. It's okay if you're inside the block. Similarly, this one has an invoices outside, invoices inside. That's fine. But the one inside is doing what we call shadowing the one on the outside. So that inner query has nothing to do with the outer query. Okay. Correlated subquery. First of all, they are, this is the same one we ran a minute ago. I have a outer query and an inner query, and in the where, I'm talking about both tables by two different names. That makes it a correlated subquery. So in other words, I'm passing stuff from my outer table down to the inner table to make decisions. I think I give you one or two of these on the exercises. We can look at them and I'll be happy to help you on them. Dr. King's example is slightly more complex than this, but do go watch this video. It is a good video. He's got some good points. I've taken a lot of his stuff. Questions? I'm going to pause the recording now and resuming recording. We have one more little topic to cover and then a review, and then we will. Okay. This is called derived tables. Up until now, all of our subqueries have taken place in the where clause. So I've just shifted to page, I'm now on page 5. Everything that we've been, it's been where some value is in, some value is greater than, less than. And it's also where usually everything comes from the outer table. It's very difficult to retrieve something from an inner table. But we can. We can. A subquery may also appear in the from line. And this is really quite handy. From clause, we look at, we want the vendor name for each unique vendor ID, but we do not know that the vendor name is unique. Therefore, we must group by the vendor ID. If two vendors are in different states, they may well have duplicate names. And you must not return any other fields. Okay. I don't know. If you look at our data, the vendor names are unique, but that's just an accident. We don't know it to be the case. So I want to check, I want to filter out let's see, what is this? Select vendor ID, vendor name from vendors as V, invoices I. I'm going to need to look at this. I think I need a distinct in this outer query. I'm not sure there. Okay, I can have a subquery on the from line because it goes to the idea of what does a query return? And I've asked that before. Okay, so what does a query return? The answer is always a query returns a table. So the result of a query is a table. Therefore, I can select from a query. And we're going to see that I can save SQL as an object and give a query a name. Some of you guys have done Access. Have you ever worked in Access, any of you? Have you taken the 1407 class? The ITSW 1307, excuse me here. I don't think it's particularly useful in this class, but when you write a query in Access, you give it a name and save it. And it acts just like a table. Well, we can do that in SQL also. We just typically don't save a query. It just runs. But many times, if you have one you're using all the time, you'll give it a name and save that query. And we'll do that in the next few modules. I don't know where. So I can select from a query. Essentially, that's what it is. Now, notice there's some things about that query, and there's some things there that are written in red. Select some stuff from a query. Okay, couple of issues here. If you have a aggregate field or a field that is a calculation, that field must be named or aliased, if you like. Okay. Up until now, it's been kind of optional. It isn't optional for me because I don't like having a column that is unnamed. That column, if it's part of a subquery, that column must be named. The second thing that you have to do, even though you probably won't use it, is you must name the subquery. Okay. It is a table. It is used in the query. Therefore, it has to receive its own name. The biggest mistake people make on these things is they will have an aggregate query. Now, remember back in the last chapter and the last module, I'm going to go back one previous. Oh, I don't want to go to correlated queries. Let's go. Notice that when I said where it's in, I did not have to name that subquery. I didn't have to say select max invoice total from invoices, close parentheses as X, or give it a name. When I'm doing it, when I'm taking it on the from line, I must give that subquery a name by which it is known. So essentially, I'm naming the table that is returned by that subquery. It has to have a name on the from line. The other thing is I'm allowed to have something like this, where I have an aggregate column in there that has no name. It doesn't hurt anything if you got the subquery on the where line. No problem. Most of the time I don't. You could have said max invoice total as M or something like that would have been okay. When I move down and I am selecting now, I have a subquery on the from line, what it's calling a derived table, if you like. these two items are not optional. You must name all of the fields in the subquery, and you must name the subquery. I typically don't worry a whole lot about it. I use a lot of names like X. I think I said MyMax, and as D, I think that stands for derived. But whatever, I have to give them both names. Like I said, I tend to use single letter names here because I don't use the name a whole lot. Okay, had we been allowed to have returned the vendor ID, many times in a query, we do not want extra information. So basically, I have to have the vendor ID I don't believe that I can run this without returning the vendor ID because it is the group by. So if I'm going to group by vendor ID, the vendor ID has to appear on the output line, but I don't want it on the output line. So look at the inner query. The inner query is a join. Select the v.vendor ID, vendor name, the maximum payment. I have to, since I am getting the payment total, I have to have both vendors and vendor ID because payment total is in both of them. They're joined on vendor ID, grouped by vendor ID, vendor name. And, oh, it's that group by that causes it. So this says if I have two vendor names that are the same, I have two TIC, three initial companies, okay? Two of them are named the same thing. If I say group by vendor name, if the names are the same, they will appear in the same group. Are you with me? And it's quite possible that you could have two vendor names. But they have to have two different vendor IDs because the vendor ID is what makes them unique, not the vendor name. Same thing for people. It's quite possible to have two people with the same name, particularly if you have a name like Smith or Jones. I'm gonna collide with lots of people. Well, I'm always glad that my middle name is Winfield. At least it's unique. Very few people named Winfield. There are some. So I have to have the vendor ID in the group by, but I don't want it in the output. So I use the subselect here, and I select from a query where I return the vendor ID, vendor name, and the maximum payment total. Notice that I give that guy a name, MyMax, down there in that subquery. What do I select in the outer query? Simply vendor name and MyMax. So notice that the name, MyMax, is visible from outside the subquery. I don't ever use the name of the query, but I have to give it a name. So this guy down here where I close the parentheses and give him a name, really doesn't matter what you name that. You just have to name it. If this table that I have given the temporary name D to appeared in a join, if it were joined to another table, and it very well could be, that'd be getting a little complicated. I think that would be above and beyond the Call of Duty for this class. But I could join D to some other table. The primary key of D, of course, would be vendor ID. So D.vendor ID is equal to something. Equals some foreign key. Questions? Had we been allowed to have returned the vendor ID, the inner subselect would have done it. However, adding fields to returning anything that you weren't asked for is considered a big no-no in SQL. So I didn't make a big thing of it, but if I told you on the test to show me the name and the phone number for some vendor, and you said select asterisk, that was a mistake because you gave me more information than I asked for. Lots of times the information is confidential in there, so you don't return anything else that the query doesn't ask for. I'm going to talk more about that in the future, about having information that is confidential in a table and allowing somebody to view the other information. So if you write a query that returns other information, it's wrong. In this case, I guess the vendor ID was like a social security number or something. You weren't allowed to return it. So this could be, I want the person's name and some maximum minimum information, name and maximum year of salary or something like that. And if their names are the same, I want to check their social security number and make sure it isn't. So I have to group by social security number and person name, but I don't want to show that social security number in the output of the query. A derived table may participate in a table join. Textbook example on page 201. So this is just a table. Once I say as D, D is a table. It can be inner joined with something, outer joined with something. Perfectly legal. It can do anything, any other table. So this table named D comes into existence. He has three columns and however many rows that subselect returns. When he executes, he becomes a table that exists for the purpose of this query. The issue that you get into with these is many times your data are constantly changing. So lots of times, particularly if you're working in an airline reservation industry, and you pull up something about the airline reservation, just as you pull it up and display it, somebody else buys that seat. Now the information you have is not accurate. So when you sell that seat, it might be invalid at that time. Okay. Back in the old days, when they did airline reservations, back in the old days, meaning 20 years ago or so, I guess that's the old days, what they would do is they just sell the same seat to two different people. And when they realized the mistake, and they would catch the mistake later, but right at the point of sale, they haven't caught it yet. They'll catch it later when they try to reconcile their records and count how many people are on the airplane. They'll realize, wait a minute, we got two people sitting in the same seat. It was just easier to flip a coin and bump one of them and say, I'm sorry, we sold the seat. And then if they screamed too loudly, they'd give them a voucher for $100. It was cheaper than fixing the problem. Today we have that fixed, but the question is, when I bring up this subquery, select vendor ID, vendor name, maximum payment total from vendors, I'm going to bring back a table. How do I know that by the time the query completes, the data in that table are accurate, or do I know that? Because remember, I've got everybody in the world hitting these same tables. That becomes a thorny issue. Okay. We're going to talk about that. That's what we call concurrency control, where you have many users logged in and updating the same tables. SQL Server allows 2 or more people to log into the same table and update that table. It also allows you to say, I need to make sure that nobody updates this table, these rows, until I finish, till I get my information. And then I say, okay, I'm done. Now you release those rows. And that's fine. But if you have a subquery like this one that's returning lots of data and you lock all of those rows, we have a problem. I used to work for Austin Community College in Austin, Texas, of course. And we had our janitors, when they cleaned the bathrooms, they didn't like to have to wait for each individual bathroom to empty, so they would go along and put the signs in front of every bathroom in the building that it was closed for cleaning. And then they would come along and clean them and pick up the signs. Well, that went over like a lead balloon. They locked every bathroom. Nobody, there wasn't a bathroom to use. While they were cleaning one bathroom on the top floor, as they were working down, the rest of them were just sitting there locked. And that's the kind of thing you want to avoid, even though it's easier. Just say, okay, I'm going to lock the whole table, not let anybody else in here, and then go through and do what I need to do. That is the way Access works. That's one of the problems with Access. You have to lock the whole table, and only one person can update a table at a time. A lot more on that coming. Okay. Let's see the next. I believe this is the quiz. There's the quiz. Quiz pretty easy. Exercises. Following query as a table join returns a list of the vendor names who have at least one corresponding entry in the invoices table. Select distinct vendor name from vendors as V, enter join invoices I on the, so it's just a plain joining of vendors and invoices by vendor ID. Very plain, vanilla inner join. All I want is a list of all the vendors who have at least, I think I'm going to get 34 here. I don't remember exactly. Pretty straightforward. You can run that one and see what the output is. Now, write a similar statement that returns the same rows and columns, however, using a subquery. Oh my goodness, how are we going to do that? By the way, I don't need the distinct in this one. I mean, I need the distinct in the inner join, but I don't need distinct. Help me out. We're going to finish this one. Or instead of writing on the board, I guess I'd better write on Notepad so that my people watching the recording can see what I'm saying. I'm going to shift over to Notepad. So this is what we want to accomplish. I'm going to copy him, drop him into my SQL window, and I'm going to execute him. And let's go look at the rows we got. 33 rows. So I have 33 vendors that have at least one invoice. Had I not had distinct there, I would have gotten duplicate vendors. That's fine. Okay, task. Write that using a subquery. Well, the select line will be the same, but I don't think I'm going to need the distinct. Vendor name from what? From vendors. So that's going to give me all of the vendors. Where? Vendor ID, saying says, is in invoices. Let's see, this still has order by on it, so the order by is going to stay the same. This should give me the same 33 rows. And I got the same 30, I got 33 rows anyway. And I believe them to be the same. They better be the same. Probably the bug. Okay. So here we have the same one. So it's a plain vanilla inner join rewritten as a subquery. Most of the time, an inner join definitely can be written as a subquery. The thing that makes it a candidate for a subquery is if all of the data come from the outer table. I cannot see into the invoices line. I can't see the invoices table. I cannot retrieve or return data from the invoices table. So I have an inner join happening here, but everything has to come from one table, that outer table. Typically, that is one of the restrictions on a subquery, but many times that's what you want. I have to join the tables to get the information I want. Questions? If I have to take something from the invoices table, so if I wanted vendor name and something about the invoice total or the invoice date or something, the greatest invoice date, then I would have to use a table join. Questions? If I have to touch both of those tables, the only thing I'm doing with the invoices table in that example is I'm using the invoices table to qualify which rows I want from the vendors table, just those that are also in the invoices table. Now it is meet for a subquery. And as I say, I tend to think that a subquery is more intuitive. Questions? Let me see if there's anything in these exercises that okay, this is a average. It's a subquery number 2 is also in the where clause, and where it is greater than, the where clause selects the average. I want you to say greater than all. I give you the, as an example, I gave you this. Here's a correlated subselect. How do I know it's a correlated subselect? This is the one from our example. What is it that cues me right away? Oh, that's a subselect, correlated subselect. Okay, they're both aliased, and if it's not correlated, I don't need to alias them. I can, but there's no reason to. And in the where clause of the subselect, look at the where clause of the subselect, one that's highlighted. What's calling my attention to this fact that this one is correlated? It uses both of those aliases in the where clause of the subselect. Yes. And let's see what I want you to do with this one. I guess I skipped a line there. Rewrite the query such that it returns the vendor name. Okay, how are we going to put this? How are we going to return the vendor name? I want, instead of the vendor ID, I want the vendor name. Well, I'm going to start with this one. Copy. Come over here. Paste. I'm going to get rid of that completely blank line. And let's see what we get when we run him. Execute. I got 34 rows. I believe that there is an invalid vendor ID in here. I believe I have left you one invalid vendor. Oh, yes, there it is right there, number 15, 999. That is an invalid vendor ID. This is why we get 34 rows from when we answer this, this question. I'm selecting it from invoices, but when I select from vendors, I only get 33 rows. This is because if I were to select the vendor ID, if I were to add vendor ID, and I could add vendor ID, I would not see vendor ID 999 because there is no vendor ID 999 in the vendors table. It has invalid data in there. I put it there. So that'll be something later. Later, I'll ask you to, hey, go find it with an SQL query. You can't just tell me it's 999. That doesn't count. You have to find it with a query. But that's why we're going to see a different number of rows when we go to vendor name. Okay, so what we want to do is we're going to get a different number of rows. We're going to be one lower on the rows. So what do I have to do? Instead of vendor ID, I'm going to copy this again. And let's make the changes here. Instead of vendor ID, I want vendor name. Well, that was easy enough. So all I have to do is execute it, right? Right. Oh, no, I got red writing. Invalid column name. Right here. Don't worry about the red squigglies. You can turn those off if you want to. I'll let you look up how to do it. G. Why am I getting invalid column name? Okay. Oh, I got to have vendor table. Okay. Where do I do the join? No, I don't believe so. If I did it in the subquery, I wouldn't have access to it in the outer query. It's got to be joined. You can have a join in the subquery. You know, it can be, but that's getting a little wild. The join happens in the outer query. Inner join. On what? Okay. So he's been aliased, so I'm going to have to use that alias. On. Let's see, where's the primary key? It's in, yeah, primary key that we're interested in is vendor ID. Have to use the alias dot vendor ID equals v dot vendor ID. So now I've added in the table I want, and now I'm able to take vendor name from this table. Since he only appears in one table, I do not have to qualify him. It is not wrong if you do qualify him. It's not wrong if you say v.vendor ID. That wouldn't be wrong at all, but I don't have to do that. So I'm not. And thank you. Group by vendor name. And here I've got my 33 rows again. I could look at them and they take a look there. They are. This one would be vulnerable to duplicate vendor names. So that would be a question you'd have to ask. I'd probably leave the, let's see, I'm curious if it will let me group by vendor name. I only have vendor, and so we'll just go V. I'm curious if it will let me group by vendor ID if I don't select it. Nope. So I have to select it if I'm going to group by it. I didn't think it would. Oracle won't. I don't know why it won't let me group by it. There's a good question. Suppose I want to group by something, but I don't want it as part of the output. That is a good question for a derived table where the table is in the from line. I'm not going to get any wilder on this one. This one, I have to have a join. I've got the join. It's just a plain old table join. There is nothing special about the table join. It's just that the where clause has a subselect in it. So this particular one, there's that where clause is just goes along for the ride. Questions? Look through any of the others. Okay, number 4 is a correlated subquery. I will take that on a case-by-case basis. I want you to have some fun with it. I will address it in lab. I'm about to sign off on the recording now. Number 4 is a correlated subquery. So it's kind of like a self-join. You might try writing it as a self-join first, just to see how it works, and then think of it as a correlated subquery. So you're going to have an outside table and an inside table. Both of them will be from the GL accounts. So go look at the GL accounts table, get an idea of what's in there. That's called general ledger accounts. For each account number that has never been used, where never been used means that it does not appear in the invoice line items. So I'm looking for a table for something in GL accounts that does not appear in the invoice line items. Account number and account description. Anyway, I'll help you on that one. Questions? Okay, I'm going to wrap up here. It is 11:52, so it's time for me to end the recording. And